scalar multiplication of 2D vectors. So when we talk about the word scalar, it's really just referring to its magnitude. So if we have a vector A and we multiply that by a scalar quantity, so just a number, 3, what happens is that vector increases in size by 3 times. So if its length was 1, its length would now be 3. And we can also call that vector 3a now. So if we had another vector b, and we multiply that by a third, that would shrink down the vector by a factor of a third, and this would be a third of b. So with vector notation, we usually denote that a scalar quantity can be given by a lambda. So this is the symbol lambda. Now, what we can have, if lambda is greater than 1, we're increasing the size of the vector. So the vector obviously increases. If lambda equals 1, the vector will stay the same. And if lambda is less than 1, the vector will decrease. Also, we have to be careful if that scalar quantity is negative, it'll flip the vector around as well. So let's think about this vector A pointing directly up. And if we multiply by negative a half, the negative will flip the vector around and the half will shrink the vector by a half. So we'd expect something like this, where this would be negative a half of A.